Alright, so let's just verify that this is alternating. Let's put in a negative 1, excuse me, let's plug in 1 here. That's going to be a positive 1. So negative 1 squared, this is 1 squared over 2 squared. Let's plug in 2, so this will be negative 1 to the third, 2 squared, 3 squared, plus plug 3 in here. I get negative 1 to the fourth, 3 squared over 4 squared. So this is a quarter minus 4 9s plus 9 16s minus 25 36 plus dot 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 dot. Feels alternating, so we'll go with that. What happens to my limit? So the limit as n goes to infinity of n squared over n plus 1 squared. Notice again that I'm not dealing with a negative 1 over negative 1 to the n plus 1. I'm just going to find the limit of the series without that. Hopefully we're all okay with it. This is going to be going to 1. Let's just prove that. Multiply top and bottom by 1 over n squared. So this becomes the limit as n goes to infinity of 1. If I move this in here, it just becomes 1 over n. So this is 1 plus 1 over n squared. So this whole thing is 1. This does not go to 0. That's one of the criteria for the alternating series test, is your limit needs to go to 0. So this goes back to our first test that we learned, which this is a divergent nth term test. Again, you have to remember that alternating series test, it was really built for the harmonic series to make this converge. So in its current form, the harmonic series doesn't converge. However, if we make it alternating, it does converge. And remember, the limit as this goes to infinity of n is going to go to 0. I can show it's decreasing. I can show it's divergent by harmonic p-series. So alternating series test falls apart if the last term is not equal to 0. So therefore this one is not an alternating series candidate at all, even though it looks like it's an alternating series, because the last term has to go to 0. It goes to 1. That goes back to the first test we learned, which is divergence. Divergence by the nth term test, or divergence test, and then we're all set. So this wasn't really part of the problem. That was just a little side note.